Hi, I'm Arch Woodside, and this is a course in fuzzy set qualitative comparative analysis. I'm a retired marketing professor at Boston College, and this course is designed for beginners to learn how to actually use the software to analyze data and forecast outcomes from the data. And so each video is less than 20 minutes long. By the end of lesson 3, you're going to be able to actually use the program, and we'll do some analysis all within 20 minutes. And so I have some specific suggestions for you in this first lesson and examples of what we use case-based outcome predictions for in research, not just in marketing, but also in management, international business, tourism, and a host of disciplines. fsQCA actually came out of sociology in particular, and also mathematics, and it's based upon complexity theory principles, and those are covered in lesson 4. And so I think you'll enjoy it. And so let's get started, okay? And so in this lesson 1, it's just a taste of fsQCA. And this guy here is Lofty Zeta, and he's really the founder of the field. There's other contributors, but he's a recognized leader in fuzzy set analysis. And he came up with the expression computing with words. And that very much fits with the idea behind fsQCA. So I think the meaning is very clear with a couple of examples. I just want to mention Lofty Zeta. He died just a few years ago at the age of, I believe it was 97, and he comes from Iran. And his work today has been cited about 131,000 times. He has 7 to 8,000 citations per year. That's what these bars refer to, the number of citations per year. And his most famous article is on fuzzy sets. That's the title of it, and that article alone has over 100,000 citations. If Lofty Zeta is the god of fsQCA, the head disciple or main prophet would be Charles Reagan. He's also now he's a retired professor. He's still very much alive and working. And a background book by Charles, he wrote the software fsQCA, and a background book, if you'd care to get a copy, is entitled Redesigning Social Inquiry, Fuzzy Sets and Beyond. It's a great title if you think about it, Redesigning Social Inquiry. You can get it for about $8, a used copy at Amazon, and it's very readable, and I highly recommend it. Okay, before Zeta, Boole, a mathematics professor, George Boole, was the originator of Boolean algebra, so it's named after him, where you put together an algorithm, which is a screening statement, and it's used by all libraries. For example, if you go to a library and ask for a book, how did they go about finding it? Well, they use Boolean algebra to do so. So I'd just like you to know the background on this. He died at the age of 49. He had a heck of a career, fabulous career, and is a recognized genius today in his development of Boolean algebra. All right, so we use Boolean algebra to construct screens that identify cases of interest. The idea of cases of interest is like police officers stopping someone because you fit the description. You are a person of interest. Here's a guy with a hoodie and a backpack on. A number of times that's been enough of a screen. Oh, look, there's a guy with a hoodie on and a screen. And this guy happens to be a white guy. You can see his hand there. And but it doesn't matter if you're white or black in this. If you have a hoodie on and a backpack, particularly in the United States, that might be enough of a screen to stop you, and because you were a person of interest, okay? Because you fit the description, a man with a hoodie and a screen on. So that gives you an idea of what an algorithm is. All right, here's a cross tabulation of data where we have 4 prices. This comes from an actual field experiment. And it's an unobtrusive field experiment, meaning that the customers did not know that they were in a study. They go in to buy something in a hardware store, and they walk up to the counter, and the salesman tries to sell them this product. And I'll give you the reference and the details at some point. But main thing I want to say is that field experiments, particularly unobtrusive, where the cases do not know that they're participating in an experiment. It's sometimes called the queen of science, the methodology, because of the design. And we at some point we'll talk about field experiments. I will mention one book, Experimentation in Marketing, 1965, by Seymour Banks. Good, great reading on this topic. Anyway, look, you got 4 prices, and you got 2 expert conditions where the salesperson says about 3 sentences on this separate product, and he actually provides information or no actual information about the product. And this purchase pal is a condition where the shopper is either alone or with somebody. And then the outcome that they're looking at is purchase or non-purchase. And here you see an instance. There's 15 people in the first row here, where they were told that the price of this new separate product was $1.98, and the salesman said something about how it works, and these 15 people had an expert, had a purchase pal, a friend or a relative shopping with them, and you see 13 out of 15 bought. So the outcome per case, you had 15 cases and 13 out of 15 bought. And the algorithm would be low price, expert, and purchase pal. Those 3 in combination led to over 80%, something like 90% actually purchased. And then so this would be called a 4x2 experiment. Purchase pal is not a treatment condition, but price and salesperson expertise would be called treatment conditions, because they're manipulated by the researcher. But purchase pal is called a measured or chronic condition, but that data were also collected when this experiment was run. So this turns out to be a 4x2x2, with purchase or non-purchase being the outcome condition. Notice there's 150 people here with the control condition at the bottom. 30 people were not given a message by the salesperson, and also purchase pal wasn't recorded for the control condition. So our job today is to get information out of these data, this table, for example. These data are from a true experiment done in a retail store. 150 customers participated. So look, one possible model that we could use here is price is $1.98. Salesperson gives the expert condition, shops with a pal, and almost all customers buy the product. So this is what that model would look like. Low price in combination with expert condition and purchase pal leads to purchase. And it does. Just imagine if you walked in a casino and you won, you played 15 times at gambling, one of the gambling venues in a casino, and you won 13 out of 15 times. I mean, that's a very, very high odds ratio where you win 5 times out of 6. So the odds are 5 to 1. You don't win every single time, but you win most of the time. So a model 8, you can come up with a model where you charge a high price and the salesperson is non-expert and the customer is shopping alone. Notice what happens down here in model 8, or the 8th condition down here at the bottom. The high price and non-expert and the no pal is present. Notice that 0 actually buy the product in that condition, 0, and 20 people experience that condition. And so this is a model of the negation of purchase. And the negation of purchase is simply 1 minus the purchase condition. All right, so and this is what it would look like if you put it in a little bit of mathematical statement, where the mid-level dot represents the Boolean and condition operation that these dots right here, the 2 dots here. So think of this as a ninja warrior, different stations in a ninja warrior contest, where you have to complete every station. You can't be excellent in 1 and 6 out of 7. You got to be pretty good in all 7 conditions. And this program is sometimes shown on television, where you get dunked in the water if you can't complete one of the exercises. We can convert this table into an Excel spreadsheet. Notice we have 15 cases in the first row, and the second row also has 15 cases, and all the cases in the second row do not have a purchase pal present. And but notice that in the first 2 rows, most of the people bought in each of those 2 conditions. So purchase pal, present or absent, really didn't matter much. And the rate of purchase is slightly lower in the second row. All right, so we could take a few minutes now and create an Excel spreadsheet, but we're going to wait until lesson 3 when I have a short example of actually doing that. And we take the Excel spreadsheet and use it with the software, the fsQCA software. So and to make it simpler, I just show 6 cases from the data, 2 cases with the $1.98 price, 2 cases with the $2.98 price, and 2 cases with the $3.98 price. And so instead of 6 cases, we actually have 150 cases. But one thing about fsQCA, typically, because it came out of sociology, most of the studies from sociology were not experiments. They were survey type data, and they typically had less than 30 cases. But there's no reason you can actually use fsQCA on 5,000 cases if you wanted to. So don't feel that it's limited to just 6 cases or 30 cases. But there's lots of articles published with 6 to 10 cases, for example, that use fsQCA. The numbers in the red is the conversion of the raw data into calibrated data, and calibration is what we actually use in the software, where you convert the raw data into calibrated membership scores. And for example, in calibrated data range from 0 to 1.0. So in F, column F, price underscore C, which stands for calibration. This is actually the scoring for the high price condition. And over here, price is shown as a variable, price ranging from $1.98 to $3.98. But here, price is shown as a condition, meaning high price. And so, for example, case number 6 is exposed to the high price. And so the high price exposure would be 0.99. Okay, so you've converted it. So in the range of values for a condition is always between 1.0 and 0.00. Now I use 0.99 simply because the software sometimes is finicky and doesn't like 1.0, and it'll close up on you. So I'm using a range of 0.99 to 0.01. And the difference between a condition and a variable is very distinct. A variable would include such things as gender, as well as price and age and so forth. Income would be a variable. But if you say a condition, you're saying, for example, a male would be one condition of the variable gender, and price, high price would be a condition of price, and pal present would be a condition of pal. Pal absent would be another condition of pal. Same thing for expertise. And all right, so we think in terms of condition analysis, and looking at simple outcome conditions such as purchase, or a combination of outcome conditions such as purchase with high expenditures combination. All right, so and we're actually look at the idea of complex outcomes, not just simple outcomes, though most research today in the journals looks at simple outcomes, single outcomes, and not joint outcomes. But there's no reason why you cannot look at joint outcomes. You actually can. All right, so and this slide actually shows a model. A model would be, the model is column J here, low price combined with no pal present and expert. Again, the mid-level dot is the and. All three have to be present. And notice here that for the case 1, all three are present. And the lowest score is given for the score for the outcome condition. Lowest score among the three. And that indicates the shared membership in the three conditions by case 1. If you look at case 2, for example, the combination of the negation of price, which is 0.99, in other words, low price, combined with no pal present, combined with expert. Now, case number 2 did not see, it did not hear the expert message. So that's a 0. So the combination score, but it's called the configuration score for case 2 in this model is 0. And so if we look at all 6 cases here, one case got the exposed to this particular configuration, the 0.99. Now, more than in the full data set of 150, there was more than one person exposed, but every time that person was exposed to these 3, jointly exposed to the 3, most of them bought. And we know the model works quite well in predicting purchase. All right, so that's the way to think about the idea of configurations and models here. And this table here shows let's see, purchase. It shows the computation of what's called consistency and coverage. And we're going to talk about that in lesson 3 instead of today. But let me just say this: consistency refers to the accuracy of the model in making predictions. That's for the high scores in the model. And again, this is a model right here in column J, shows a model. And does this model work well in predicting high scores in the model? And one thing I want to mention here is that this is asymmetric prediction. You're just predicting people who have high scores in this model will have high scores in the outcome, and the outcome here is purchase. And you're not predicting symmetrically. You're not predicting low persons exposed to this model will have high or low scores in the outcome. You're not saying they're going to have low. The only thing look, if you walk into a casino and you found you have a formula or a model that works, you're not saying that other models do not work. Other models could work as well. All right, so we'll come back to that point later. Now, a beautiful thing about an algorithm or a model or formula is you can show it on an x-axis. And what you can say here is that you can put in the scores. By the way, that's my cat in the background, just to keep this. I'm not an artificial intelligence here. This is a situation where we actually have my cat showing up for this program. So look, we have one person here that got exposed to this combination treatment, and that person bought, okay? And we have one person that was exposed to had a membership score of 0.5, and that person bought. And we had 2 people buy who don't fit the model, so they have a low score in the model, and they also bought. We don't care about them for this model. All we care about is the one person who did buy, one person who does fit the model actually purchased. All right. So the beautiful thing is, again, we can look at the data in terms of an XY plot where the outcome is the Y and the input, the antecedent condition, is a complex statement. It's computing with words, combination here. And so cases having high scores on the X, if the price is low and no PAL is present and salesperson gives an extra condition, and that's what we have here. And you can plot the 6 cases, you can plot 150 cases on this. All right, and so just want to mention here, this is a symmetric relationship where all the values are given by letters, and if you're high on X, you're high on Y. Real life is not symmetrical. That's worth repeating. Real life is not symmetrical, but what life is tends to be asymmetrical. And here's an example of asymmetrical. High on X, you get some high on Y, but high X is not sufficient to tell you that all the scores will be high Y, because a number of the scores are high in X and low in Y. So this is called necessary, but insufficient for indicating high Y. And here we have the asymmetrical findings. And this is what we're looking for, that the model works quite well, that everybody who's high on X or high on Y. Isn't that exciting? Everybody who's high on X is high on Y. That's all you want to be able to say. All right. So this is where you don't have any information coming out of the data. It's very important to look at your XY plots in fsQCA, and we're going to do that today. And the guy who said that, by the way, and showed it is Anscombe. He's a mathematician in the early 1970s, and there's something called Anscombe quartet, and we'll talk about that in the first 5 lessons of this program. So this is what we've just got done talking about. So this concludes lesson 1. The kernel takeaway is you use fsQCA to construct combinations of conditions that predict a simple or complex outcome condition. Your combination of conditions is a screen, also known as a model or a formula. And hopefully your model is accurate in predicting your outcome condition. So I'm very happy to have this meeting with you, and I hope you join me in lesson 2. And so let's keep in touch, and you can contact me anytime by email, arch.woodside@bc.edu, and that's in slide 1. So take a look at that, and please join me in lesson 2. Thanks very much.